last week.
Okay. Now, I think it's a very good idea. You know, I don't know. This is the way we have been doing the institute for a long time, but from time to time, I'm reminded of the fact that it's really a wonderful idea that you go through it and then we talk to you or walk around. Because in the process, I realized some of you forgot why I'm doing this. Now, I told you, mathematics is strictly goal-oriented. Every step, if I want to describe to you what mathematics is, I summarize in one sentence. I have destination, I have A, I have point B. I want to go from A to B. That's all there is to it. That summarizes all of mathematics. Now you should stop and think. If you say, oh, at some point I did not do this, and you know what I'm going to say to you? I say, well, at that point you were not learning mathematics correctly. That's simple. We are always going from one point to another. Of course, what is the vehicle that allows me to go from point A to point B? That vehicle is what you call mathematical reasoning. Right? So there's no question. You have to know what you're doing. Keep that in mind. That will make your learning and your teaching much clearer. So in this case, what's point A? Point A is, I'm assuming you know how to do the house business. You know what? I'm not going to talk about it. I never talked about it. Point B is what? Complete explanation of that funny process. Right? So this is why you have to write this down. Because this is a sensible recapturing of what the house is all about. This is entirely the same thing. This is entirely the same thing. Therefore, now in a real sense, now point A becomes this. Because they're the same. And now I have to tell you, on this basis, how do I get here? Of course, the Q now replaced by 146 and R replaced by 4 or 3. So you're explaining something. Therefore, you will have to begin with the little house to show what you're trying to do. And then you should remind yourself from time to time, or maybe every step, that what you want to achieve is to be able to write this. Okay? Don't forget that. Don't forget, mathematics is entirely goal-oriented. There's none of this thing about, well, here's the problems. Well, you just fool around, investigate a little bit, explore, you feel good. Good. None of that. Yes, those things serve a purpose. When you're frustrated, you will just want to fool around. We fool around all the time. But we know we're not getting there, so we just make no mistake about it, right? Just know, I'm just waiting for a chance to get ahead, but now I'm exhausted, so that's okay. But you still want to get there, right? So that's the first thing. Please remember what you're trying to do. Your goal is to explain that monkey business, right? Now the second thing is, when I teach this institute, depends on what I teach, of course, but in this institute, for example, we've been doing fractions and we're also doing whole numbers. Now, I don't care what you learn from this institute, I can't control that, right? But I do have two requirements. One is, in this case, because we're doing fractions and whole numbers, I tell you what, the two minimum requirements for you to walk out of this institute after 3 weeks, right? First one, this statement, this statement about division of 879 by 6. Now, if ever I catch you writing this, or 3, all the way there. 3. If I ever catch you writing this,
Bad.
I'm going to write the Governor Brown and get you to jail.
What if you put DWB in front?
What?
What if you put DWB in front?
No.
Just joking.
Put DOA in front.
Yeah, that's good. Don't you dare write this. Now, of course, this is part of the reason kids don't know what division is, because for this, they use this symbol. For the real division, you also use the symbol. After a while, who knows what's happening? And by the way, this is a very sad statement. I mean, you think I'm just doing it because some personal quirks, right? None of that. This obstructs learning. I'll give you a concrete example. Because people don't realize that there are 2 kinds of division. They think that division with remainder is also honest division as an arithmetic operation. What happens is not very pretty. That's a national document of great prominence that talks about middle school mathematics, and of course they have to deal with division of fractions. It's in black and white written and say, you can achieve conceptual understanding of division of fractions by looking at repeated subtraction. And to repeat, the official statement is, you can achieve conceptual understanding of division of fractions by use of repeating subtraction. In other words, what they say is, I have no room. You can do it like this. So you say, that's the formula over 9 divided by, let's say 1/3, right? What they say is, subtract a copy of 1/3 from it, see how big it is. Subtract it again, see how big it is. Subtract it again. At the end, well, of course, if you can, you should start doing it now. Just see what happens. And at the end, you come to something very, very small. Well, then you see, so there are so many copies of this in here, but so there's something left over. Yeah. But that's okay, you can estimate it. How did that come about? Well, because that's the problem originated here. They confuse the fact that division with remainder is the same as ordinary division. Therefore, if it works for whole numbers, if a little bit is good, a lot must be better, right? Therefore, it works for whole numbers, must work for fractions. Therefore, when it comes to fraction division, apply this. That's division. Yes, this division. Apply it to, and then you achieve conceptual understanding. I mean, something like that is like that. So I don't want you to make those mistakes. This is a separate entity. Of course, you know quite well, right? You cannot, fractional division cannot be a quotient and a remainder. Doesn't happen. Exactly. Why don't you know how, can you read off? We haven't done anything, but you know how to do it. What is it? What's the answer?
49.
What number? No dream, no. As it should be. Division is an arithmetic operation among fractions. Give me the 2 numbers, I give you. Right? This is why we should do things correctly. Okay. I think we better stop and come back at 20 off.